Hello everyone, welcome back. Today I am going to explain a problem on design of shear. A simply supported beam is 120 mm by 300 mm in section and has a span of 10 meter, is pre-stressed with parabolic cable which has a maximum eccentricity 100 mm at mid-span and minimum eccentricity 20 mm at support. Effective pre-stressing force in the cable is 300 kN. The beam carries all inclusive UDL of 30 kN per meter. Determine the principal tension at 0.6 meter from left support and 20 mm above the centroidal axis. In this problem, they have given a rectangular beam of cross section 120 mm by 300 mm. It is having a span of 10 meter. This beam is carrying a total load of 30 kN per meter. For this kind of a loading case, we need to calculate the principal tension in the beam at 0.6 meter from the left support and at a distance of 20 mm above the neutral axis. About for two different questions we should calculate. One is for 0.6 meter, one is 20 mm. Next is the diagram is not given, so write a beam carrying a UDL which is having 30 kN per meter. This NA is nothing but a neutral axis. From here to here, it's a parabolic cable, and they have clearly given this parabola have a maximum eccentricity of 100 mm at midspan. So from the neutral axis up to the parabolic cable, the eccentricity at the center is 100 mm and minimum eccentricity is 20 mm at the supports. Here it is 20 mm, this side also it is 20 mm, but at the center it is 100 mm, which is starting from the neutral axis up to the parabola. Okay, then this is a cross section 120 mm by 300 mm. I have just divided 300 into 150 above the neutral axis, 150 below the neutral axis. Okay, I forgot to say this. As we need to determine the principal tension at 0.6 meter distance from left support, I have just marked it. Okay, from the left support I have marked or I have taken a section of 0.6 meter. Next is this second part, that is this diagram is completely different from the previous one, as they have mentioned 20 mm above the centroidal axis or neutral axis. So neutral axis is here. Above that I have taken a section as 1 which is at a distance of 20 mm and the remaining portion is hatched. The remaining portion is 130 mm depth, width is 120 mm. How did I get this 130? You can see a cross section. This height was 150 above the neutral axis. So 150 minus 20, you will get 130 mm. Next is neutral axis, and this a parabolic cable. Here exactly from the center of the parabola up to the top or the maximum height of the parabolic cable, the distance or eccentricity is 80 mm. How did I get this 80 mm means already they had said that 100 mm which is starting from the neutral axis up to the parabola. Here also at the support we had 20 mm. So 100 minus 20 we will get 80 mm. So above this line it is 20 mm, below this line it is 80 mm. And this is at 0.6 meter we need to take a section. Here you can see I'm just using a formula, that is deflection of parabolic cable. Y is equal to 4h by L square into x into L minus x. This is a deflection formula for parabolic cable. Why I'm using this deflection equation is, from here up to this point, what is a height, or what is how much it has got deflected, we don't know. Okay, so at the center the maximum deflection is 80 mm, but at 0.6 meter distance, what is a y value or deflected value, we don't know. We need to find that height. So to find that height, we are using this deflection equation. And also we require slope in a formula. In further formula we have a sine theta. So to find out that sine theta, we can use this dy by dx. How we are getting dy by dx? By using this deflection equation we will get dy by dx. Differentiate this deflection equation with respect to x once, that time we will get slope. So slope is equal to dy by dx, or it is also equal to sine theta is equal to 4h by L square into L minus 2x. Next is just substitute the values for this. Sine theta is equal to 4 into 80 means this height. Okay, this height is 80, then length is 10 meter, convert that it into mm. So it will be 10 into 10 power 3 square whole square into 10,000 minus 2 into 600. What is this x value, or what is this 600 is? Here at 0.6 distance, how much is the slope also we required. Okay, so we are taking this 0.6 meter in mm, so it will be 600. Sine theta is equal to 0.028 radian is a slope here. And one more thing, why do we require this slope means, you can see here. Here we have a pre-stressing force which is in a inclined manner. So in the next diagram what we have done, I have just resolved that pre-stressing force into two components, that is horizontal component and as well as vertical component. We don't know how much is the vertical component, so we require that also. This 8400 is after calculation we have got this value. So after calculation you just write this value here. So let's see the next slide. Next is reaction is equal to WL by 2. This is a formula for simply supported beam carrying a UDL. But you can observe WU value. WU instead of 30, I have considered it as 45. Why it is 45 means, while designing we should take factor of safety for concrete as 1.5. So 30 into 1.5, that is a UDL they have given. So 30 into 1.5 will give you 45 into 10 by 2. 45 is by 30 UDL value, 30 into 1.5 factor of safety for concrete. we will give reaction at the support is 225 kilonewton. At this point, at this support, how much was the reaction means it was 225 kilonewton. Next is vertical component. As I told you that that inclined force should be resolved into two components, vertical as well as horizontal component. Vertical component is P sine theta. P is 300 kilonewton. Convert that into Newton. So 300 into 10 power 3 into sine theta 0.028 P sine theta. 1 second. If it was a horizontal component, it would have been a P cos theta. If we want vertical component, it will be P sine theta. So if we use P sine theta, we will get 8400 Newton has a vertical component. So I have written the value here after the calculation. Next is net force. Actually, at a distance of okay, fine. The next force is we should calculate how much is a shear there. So to calculate the shear, we should consider the support reaction as well as the vertical component. So this reaction is acting upwards. It is positive. So plus 225 into 10 power 3 means convert this kilonewton to Newton. So it is into 10 power 3. This vertical component is acting downwards. You can see here, if we resolve this inclined force into two components, vertical and horizontal, vertical will be acting downwards. Consider because of the downwards reaction, we should consider this negative sign. So minus 8400 will give you shear has 216.6 kilonewton. Next is AY. It is not AY, I have just corrected. It is AY bar. What is this AY bar is? It is static moment of area. How to calculate this? Go to the diagram, that is second one. Here the hatched portion is 120 by 130. So consider that area AY bar is equal to area of the hatched portion 120 by 130 into 130 by 2 plus 30. I will show you how did I get this 130 by 2 means we want a distance, that is A is over Y bar we should calculate. So to calculate Y bar, we have taken a portion or section at 1 which is at a distance of 20 mm. And half of this area is 130 by 2. So put together we require a value from the center of this above the neutral axis up to the center of this centroidal axis of the particular area. So it is 130 by 2 plus 2 plus 20. Like this we have calculated Y bar. It will be 1.320 into 10 power 6 mm cube. Y bar is over, that is static moment of area is over. Next is I, moment of inertia for a rectangle section. To calculate this rectangle section, now we should consider the whole rectangle section 120 by 300. So 120 by 300 cube whole divided by 12 into 270 into 10 power 6 mm power 4 is the answer. B is width of the section. It is given 120 mm. To calculate shear stress, the formula is 2V is equal to Vu into A into Y bar by I into B. So, to substitute all these values, we have all these terms, we have just calculated these terms. Vu 216.6 into 10 power 3 into A Y bar is 1.320 into 10 power 6 whole divided by I is 270 into 10 power 6 into width is 120. Therefore, we will get shear stress has 2V has 8.86 Newton per mm square. Next is horizontal pre-stress. Horizontal pre-stress is denoted by Fx is equal to P by A. P value we know, they have given it as 300 kilonewton. Convert it into Newton. So 300 into 10 power 3 whole divided by area means you should consider a complete area of the rectangle, that is 120 into 300. We will get 8.33 Newton per mm square as a horizontal pre-stress value, and vertical pre-stress Fy is 0. Why this Fy is 0 and Fx we have got some value means always beam is pulled in a horizontal direction, not in a vertical direction. So for horizontal we have got value, for vertical it is 0. And the final thing is principal stresses. The formula for principal stresses is sigma is equal to Fx plus Fy by 2 plus or minus 1 by 2 whole root of Fx minus Fy whole square plus 4 2V square. Here I have written sigma max or sigma minimum. How to take sigma max value is, the formula is same, that is Fx plus Fy by 2. To calculate this maximum, that time we should consider only positive sign. So Fx plus Fy by 2 plus 1 by 2 whole root of this value will give you sigma maximum. To get sigma minimum, consider only negative sign, that is Fx plus Fy by 2 minus 1 by 2 whole root of this value. We will get sigma minimum as minus 5.63 Newton per mm square. Like this we can calculate principal stresses by using this formula. But if you know theory of elasticity, in that theory of elasticity we come across these principal stresses formula. Like this we can calculate principal stresses, shear stress by using these kind of a formula. Hence you have I feel you have understood this. Thank you.